In this video, I'm going to show you a few examples of applying the power rule to find derivatives. And the power rule is very cool because it allows us to bypass the idea of using limits and the difference quotient to find derivatives. And it's kind of a shortcut for finding derivatives. And it's stated here very formally at the top of the screen, but the idea is actually really simple. So let me illustrate the power rule using an example. Let's say y equals 3x squared. And by the power rule, to find the derivative of this function, we simply need to bring that power down in front as a multiplier and then decrease the exponent by 1. So here's what I mean. So to find the derivative of y, we're going to keep the 3. We're going to move the exponent down in front as a multiplier, and we're going to decrease that exponent by 1, so that our derivative is 3 times 2, which is 6, times x to the first power, which of course we can rewrite as just 6x. So rather than going through the whole limit and difference quotient formula in order to find the derivative of this, we were able to do it in just a matter of seconds with the power rule. And before we go into a couple of other examples, let's just talk about what happens when our function is equal to just a constant. Let's say y equals 5. Remember from algebra that we can actually rewrite the constant of 5 as 5x to the 0 power, because anything to the 0 power is just equal to 1. So what this expression really equals is 5 times 1, which is just 5. So I haven't changed the inherent value of this function. I've just changed the way it looks so that we can see what happens when we apply the power rule to find the derivative. So let's do this. Let's find the derivative of y by, we keep the 5, we bring the exponent of 0 down in front as a multiplier, and then we decrease that exponent by 1. And look what happens. We get 5 times 0, which is 0, and 0 times anything is 0. So the derivative of a constant is just 0. Now let's move on to this first example that I've got here. When your function looks like one term or a string of terms added or subtracted, we can utilize the power rule to find the derivative, and the name of the game is going to be just that we apply the power rule one term at a time. So in other words, we have this function here, y equals x to the third power minus 11x squared plus 35x plus 4. And to find the derivative, we will just apply the power rule one term at a time. So for the first term, we will move the 3 down in front as a multiplier and then decrease that exponent by 1. For the second term, we will do minus 11, leave the 11 there, bring the 2 down in front as a multiplier and decrease that power by 1. And for the next term, we'll do plus 35. Remember, 35x is the same as 35x to the first power, so we'll bring that 1 down in front as a multiplier and decrease that exponent by 1. And then finally, we already talked about the fact that the derivative of a constant is 0, but again, what really is happening here is we have 4 times x to the 0 power. And so we're going to bring that 0 down in front as a multiplier and decrease that power by 1. And then as a final step, we'll just simplify this whole thing. So you're going to get to the point where you don't need to write all of this out, but just to illustrate the idea as you're kind of getting used to things, that's why I am writing everything out. But for certain, as you get more proficient with the power rule, you'll be able to zip through an example like this in just 1 or 2 seconds. So our final answer here would be 3x squared minus 22x plus 35, because 35 times 1 is 35, and then x to the 0 power, remember, just represents 1. So this whole thing really just boils down to 35 times 1 times 1, or just 35. And then as we discussed, the derivative of a constant is 0, and rather than write plus 0, we simply leave it off. So the derivative of our original function is 3x squared minus 22x plus 35, and as you can see, the power rule saved us a ton of time, a lot of paper, and maybe some frustration when we would have had to, before we learned about the power rule, we would have had to apply limits and the difference quotient in order to arrive at this same result that with the power rule just took us a few seconds. So pretty cool stuff. Now on this last example, y equals negative 12 all over the 4th root of x. We're going to apply the power rule, but I chose this example because I wanted you to see that sometimes before we apply the power rule, we've got to do some work to our function first. So let's take a trip down memory lane and recall some algebra. So remember that we can rewrite the radical 4th root of x with an exponent. I'm going to go over here to the margin here. So we've got the 4th root of x, which is the same as the 4th root of x to the first power, and we can rewrite this with an exponent by taking the radicand of x, and then the exponent is equal to the power divided by the root. And I'm going to go out on a limb here, and this may seem a little bit goofy, but I tell students, remember back in the day, the cartoon or the show Power Rangers? I don't know, when you transfer a radical to an exponential term, think of the Power Rangers. It might help you remember that for the exponent, we put the power over the root. So P for power, R for root. And I know it sounds goofy, but it actually works. So okay, let's go back to our example here. So when we rewrite this with an exponent in the denominator, we have y equals negative 12 in the numerator, and in the denominator we have x to the 1/4 power. And then we'll take this one step further, and we'll bring this term in the denominator up to the numerator by making this exponent negative. So we have y equals negative 12 times x to the negative 1/4 power. And now we have something that we can really easily apply the power rule to. So let me give myself a little bit more room here. And let's apply the power rule. So the derivative of this function would be, we've got negative 12, we move the exponent down in front as a multiplier, and we decrease the exponent by 1. So 1/4 minus 1. And when we simplify this, we get negative 12 times negative 1/4 gives us a positive 3. X to the negative 5/4 power. And just to recall how we deal with that negative 1/4 minus 1, you could calculate that very quickly on your graphing calculator, or you can recall back from pre-algebra that in order to subtract with fractions, we simply need a common denominator. So this would turn into negative 1/4 minus 4/4, and from there we would combine the numerators. So negative 1 minus 4 would give us negative 5, and keep the same denominator of 4. So that's how we would arrive at our derivative of 3x to the negative 5/4 power.